Kia ora Year 12 and 13. This video is going to work through the first 8 questions of Delta Chapter 34.7. So the focus in here is on using double angle formulae. The previous exercise in 34.6 was to just get you used to the patterns. So in this exercise, you're probably going to have the feeling that some of what we're finding out is stuff we already know, but we're just trying to practice using those formulae. So the basic version of the double angle formula is this. So cos of 2 theta can be written in 3 different ways. Cos squared of theta minus sine squared of theta, or 1 minus 2 sine squared of theta, or 2 cos squared theta minus 1. And sine of 2 theta can be written as 2 sine theta cos theta. I'll do tan when we come to it in the exercise, but it's the same idea. And you'll remember that in class we looked at how we could prove these from our compound angle formulae. Right, so question 1, we are given cos of 60 degrees equals 1/2, and we need to calculate cos of 120 degrees. Right, so we're only told the cosine, so the easiest version to use is cos of 2 theta is equal to 2 cos squared theta minus 1. And theta is going to be 60 degrees. So the cosine of 120 degrees is equal to 2 times the cosine of 60 squared, take away 1, which is 2 times 1/2 squared minus 1, which works out to be 1/2 minus 1, which is negative 1/2. Okay, question 2. Same kind of idea. We're given tan of 60 degrees equals √3, and we're asked to work out tan of 120 degrees. Well, we know that tan of 2 theta is equal to 2 tan theta over 1 minus tan squared theta. And that equals, so we have tan of 120 degrees, theta is equal to 60 degrees here. So 2 √3 over 1 minus √3 squared. Now I'm going to squish this in here. So we get 2 √3 over 1 minus 3, which is 2 √3 over negative 2. Right, so please don't do your working like this. It's horrible. Equals negative √3. There you go. That's that one done. On to question 3. Right, question 3. We are told that sine of 45 and cosine of 45 are equal to 1 over √2. Now you really should have a feel for that one already from lots of special triangle practice. But we're asked to calculate sine of 90 degrees using that fact. So we've got sine of 2 theta is 2 sine theta cosine theta. So theta will be 45 degrees. So sine of 90 degrees is equal to 2 times 1 over √2 times 1 over √2, which is 2 over 2, which is just 1. Okay, so we're happy about that. We should have known that's where we're heading from my graph of the sine curve. So there's 90 degrees there. Right, next question. Okay, there are 3 parts to this. They're all the same kind of idea. We're given the sine of some random angle. Sine of 36.9 degrees is 0.6, and we're told the cosine of that angle is 36.9. And from that, the first thing we're asked to find out is to get the sine of 73.8 degrees. So using sine of 2 theta, that will be 2 sine 36.9 cos 36.9. So that equals 2 times 0.6 times 0.8, which is 0.96. The next one, same kind of idea, cosine of 2 theta. Well, you could do this several different ways. Maybe we'll just do the basic one, because we haven't used that yet. Cosine squared of theta minus sine squared of theta. So cosine of 73.8 will be cos of 36.9 squared minus sine of 36.9 squared. Right. Now notice when I'm writing it like this, I'm doing the squared outside. You could do that either way, but once you're into the calculation, you just want to make sure that you're going to be squaring the right thing. So I guess what I'm trying to say there is it's fine to write the 2 there, but to me, once I put a number in, it feels better to write the 2 up here. Okay, over to you. And Mr. Kane and Mr. Moyer might have a different opinion on that one. I'll try and remember to check. So this is 0.8 squared, so 0.64 minus 0.36, which equals 0.28. Right, the next one is the tan one. I'm going to do that in 2 different ways on the new slide. Okay, well, the tan of an angle can always be written as the sine of an angle over the cosine of an angle. So we really don't need to use our double angle formula to get that, because we've just worked those 2 things out. And we've got 0.96 over 0.28, which simplifies to give me 24 over 7. I'm sure most of you can simplify that easily, but remember you have the luxury on your calculator of the magic FD button, so use it if you must. Now I'm going to show you that that is the same thing as doing it with the double angle formula. So we're going to have 2 tan 36.9 divided by 1 minus tan squared 36.9. So look, I'm being inconsistent because I just put my square doodah up there, and that seems fine. Right, so either is fine. Here we've got 2 times now what's the tan of 36.9? Well, it's the sine of 36.9 over the cosine of 36.9. So that works out to be 0.6 over 0.8 or 0.75. And we can go 1 minus that. Right, next slide. So that works out to be 1.5 over 1 minus, well, 0.75 squared, that's 3/4 squared, 1 minus 9 over 16. So I get 1.5 divided by 7/16, which is 24, 1.5 of 16 over 7. Not surprisingly, as before. Okay, so just showing you different ways to think about the same problem. The first way, where I just did the sine over the cosine, was much easier. If you were directed to use a double angle formula for tan, you'd need to do it this way. Okay, last couple of questions. Number 5, we're told to use this version of cos 2a to work out the value of sine 45 degrees. Right, now we already know what the answer to that is, but we're told we're given that cos of 90 equals 0. So we're going to substitute in and get 0 equals 1 minus 2 sine squared of 45 degrees. So sine of 45 degrees is equal to, well, let's do it properly, 2 sine of 45 is equal to 1, and that's still squared. So sine of 45 is equal to 1/2 square rooted which is equal to 1 on root 2. Alright, question 8 is a bit more interesting. It says to verify. So verify means that we're told to check whether it's true that if I have the formula for cos of 2a, I want to show that something works. So we know that cos of 2 theta is 1 minus 2 sine squared theta. And we're told that cos of 30 degrees is equal to root 3 on 2. Right, we know that from our special triangle. There's my root 3 and 2. So all we want to do is we're going to look at this side and we're going to check what happens if we put in root 6 minus root 2 on 4. So we're asked to verify that sine of 15 is equal to this thing. So our logic is we're going to say if I substitute that in there, will I end up getting root 3 on 2? So 1 minus 2 can be expanded like this. 1 minus 2/16 times root 6 minus root 2 squared. So we've just got a little bit of manipulation to do there. We get 1 minus 2 on 16, root 6 minus root 2 squared, so write that out, which equals 1 minus 1/8. Okay, 6 minus root 12 minus root 12 plus 2. This is good practice for when we get to complex numbers. So that's 1 minus 1/8 of 8 minus 2 root 12, which works out to be 1 minus 1 plus 1/4 root 12, which is 1/4 of the square root of 4 times 3. Many of you won't need to have this step in here, but some of you still will. So 1/4 of the square root of 4 times 3, which is equal to 2/4 root 3, which is root 3 on 2. Okay, that's all we've got time for now. I might do the last 4 later on, or you can ask me in class. Thanks for watching.